Hello dear students, this lesson will be about another cantilever beam, also simple beam stress analysis example, but for this time we will use the element type, which is beam 188. So we will see how to make this stress analysis for cantilever beam using this type of elements, using ANSYS APDL. The cross section of this beam will be a circle with radius of 20 millimeter. So let me see how to do this analysis in ANSYS. Again, for preferences is structural. For element type, this time we will select for the first time the beam. So we'll select two nodes 188 beam. Also, this element doesn't need for real constant, so go directly to material model, structural, as regular, linear, elastic, and isotropic. The material properties is 200 gigabyte, so 2 to the power of 11. The portion ratio is 0.303. 303, okay. That's all for material definition. Now we will go also for the first time in section using beam command section. So in this menu here, we have the ID is just number, the name you can call it beam, for example. Subtype you can see here, this is square, circular, any shape, H shape, L shape of beam. So we'll select the circle one. The circle has the diameter or radius of 20 mm. N and T, N it's the angular distribution for the elements through the cross-section area of this beam. So let we select 12. I will show you later to explain what's the meaning of N, and 40 it's radial through the radius of this circle, how many elements we want to divide the cross-section area of this beam. So let we select 20, and now I will show what's the meaning of N and T to be more clear. So let we see the mesh view. This is the mesh view. This is the angular division here. This 12, 1, 2, 3, enter 12, and then for radians direction here, we have 20 starting from here, 1, 2, 3 to 20 section through the cross section area of this bar. So click OK and replot to start to create this beam. So create it, okay, using key points in active Cartesian. So let we start with 0, 0, let's apply. The second one is according to this drawing is 120, so 120 mm with 0. The second one is 240 with 0. Click OK. So now let we create lines, straight lines. This one, so down. Okay. Now let's go to meshing. Size control, manual size, lines. We can pick all lines or pick lines. It's all same. This one and this one are all also same. So okay. For each lead we divide it into 10 elements. It's okay. So each line divided into 10 elements. Now we can go to mesh lines. Mesh lines. So we can select this line and this line. Press OK. So now all lines are now meshed. Now let we go to solution to apply the load, define the loads, structural displacement on key point first. So this key point is fixed here in all degree of freedom with 0 displacement here. And now let me see how to apply the uniform pressure as mentioned here, 1200 Newton per millimeter. For each millimeter there is a 1200 Newton. So let me see in ANSYS how to apply this force in y direction. So it's the pressure. Let me first plot lines to make it clear. Now apply pressure on beams and select box to be able to select these elements here. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So okay. Okay, the pressure is 1200. It's 1200 is the pressure, so no need to put minus. For uniform pressure, leave blank, so we can leave this one blank, or also we can put 1200 to get uniform pressure. So press OK. So we got it now. In isometric view, we can see the, if you didn't get, so we just plot elements to get it. So we apply the pressure here in Z direction actually. Now go to solve this problem to get the results. Current line steps, okay. The next example, I will show you how to apply the loads in specific elements and whichever direction you want, X, Y, Z. Okay, so solution done. Okay, now let's go to see the results from general post processor. Plot results, deformed shape and deformed and undeformed. Okay, so you can see here the blue color, and the maximum deformation is very small. It is 0.17 to the power of minus 0.4, so it's very small. From plot control, if you change the style to size and shape and open this display of elements, okay, so you will see the cross section, through the cross section area of the beam, how the deformation is appear here. To get the deformation in Z direction, press OK, so you will get this view. Also you can see the, for exact for stress, let me show you the stress also, von Mises stress. Von Mises stress. Okay, so you can see the maximum stress is here in the point, the fixed end of this beam. Also we can plot vectors, so you can see the deformation distribution. You can see its maximum deformation is the free end and decrease when we go to the fixed end. To get the exact values for each line here, you can go through the list of results to get nodal solution, deformation in Z direction, and then you can get it for element by element, as you can see here. Starting from Z, and node 1 is 0 deflection because it's fixed. according to our boundary conditions and go to the maximum in nodes 21. In the same way, you can get a reaction solution in all items, for example. So you can get the reaction in Z point, because the Z direction has the force, so only the reaction in Z direction, the moment in X, Y, Z direction also is available. So the exact values from here you can get it using the list of results. That's all for this lesson, and thank you very much. See you in the next lesson. Thank you very much.